So I'm Matt Jones. I'm part of the team here at the Space and Rocket Center. We're glad to have all of you here for this symposium. Hopefully it's been entertaining as well as informative, and then the network side of just meeting people you haven't met before. We appreciate our students being here today. I know a lot of y'all had some good questions for the Cincinnati Reds guy. That was an interesting talk. That's part of what we love, is bringing in different people with different perspectives on how to use AI and what the future looks like. I've had a good time getting to know Andrew a little bit. Andrew Samuelson is going to be with you today. He's with from Booz Allen Hamilton. He is an AI solutions architect with them. For over 5 years, Andrew's been a key architect for the Chief Digital and Artificial Intelligence Office's Advanta program, establishing groundwork of actionable, shareable data. As AI continues to evolve, he remains a vocal advocate for the critical role of data and metadata integrity. Today, his role is centered on defining and measuring AI success to ensure technology delivers meaningful, mission-focused outcomes that are trusted by users. He kind of gave me a really short version of what it does. Is when everything's going crazy and falling apart and on fire, they call him to come fix it. So, Andrew.
I, too, am a fan of walking around the stage, so we'll try to keep it moving. But so originally when I wrote this presentation, I was thinking about data and the data that AI uses to try to give you answers, how that might fail, how setting up agentic might work. And as I continued to build out this presentation, I actually found there were a few other lessons, but the initial name of this was AI You Can Trust, built from the data that you can't. Do we know what that is? Windows noise?
Need more tokens.
Yeah, okay. We'll reload the card. All right, well, I'll just introduce myself real quick, because that's what my next slide is, while we hopefully can get this figured out. So my name's Andrew Samuelson. I've worked at Booz Allen for 7 years. I've held a variety of roles, including data scientist, back when that was the fun term that everyone was calling themselves. Now, we've moved on, but I've been a full stack developer. I've done data engineering, worked for teaching people data engineering, worked as a data architect, and now my official title is AI Solutions Architect, with that constantly evolving every day as to what that means. A lot of what I do is very quick iterations. It's not these large, long-standing software programs, but instead, like, how can we get a solution out the door that helps people right away and can provide meaningful value? And that can even look like, how do you make other people more productive? How can you standardize something? Things along those lines. And a little bit of fun outside of work. I do like my analog media, clouds, and furniture. So if you want to talk about any of those things afterwards, I'm happy to. Okay. Oh, I'm holding the remote upside down. Yeah. So, a little poll from the room. Who thinks they can tell me what the difference between verification and validation is? And I won't call on you, I promise, but well, let's see, a raise of hands. Who has an idea of that these words are even different? All right, a few people. So what verification and validation is verification is asking, did we build this thing right? And validation is asking, did we build the right thing? And this is pretty much to say, does what we did meet the requirements that we outlined, versus did we actually set out to make a change for the thing that mattered to us? Because you can have all the requirements and get the requirements, meet them. But if they didn't meet the initial problem that you were trying to solve, it doesn't really matter. But as many of you know, this is not what ChatGPT gave me. It gave me a much longer explanation that I did not really care for, and I picked out my favorite part at the bottom, which was the answer. So another poll. Do we like polls? If I were to hand you a report, how many people would rather be handed report A if you were going to look at it? Okay. And if you had to ingest this data programmatically for whatever, it was a regularly processed sheet, how many people would want to be handed report A over report B? A lot fewer. So my question here is, why should AI be any different? Why is the data that we're feeding AI the same data that we expect a human to look at? And that kind of comes down to, like, logically, how are you preparing your data such that AI can meaningfully read through it faster, understand it better? The ways in which we previously stored data are becoming antiquated, and we need to start understanding how AI wants to interact with that data to best have it give us the results that we're looking for. So, I was going to go over timeline, but being one of the last speakers at this conference, I feel like everyone has heard about the timeline of AI. In 2023, we're seeing these, ChatGPT really hit with GPT-4, and then in late 2024, we're seeing the emergence of the idea of like agentic AI, and throughout 2025, we've started seeing these agents interacting autonomously with data, and this is just getting faster, and eventually it won't be agentic, it'll be something else, and we'll have a conference about that next year. And some of these evolving concepts we've got RAG and CAG, which are retrieval augmented generation, cache augmented generation. Some of you might not have heard about CAG. It's like a little bit of a newer idea, but it's better for when your data doesn't change as often. You're like caching some of that information for faster retrievals. MCP, which is model context protocols, it's sort of like something that came out of Anthropic. How do you interact with, how do you have AI interact with data, with other endpoints? Tool calls, these are more like deterministic functions you're writing for your AI to use. Context decay, which I've heard generally kind of talked about negatively at this conference, but in some ways it can be used like to your advantage, where maybe you don't care about the older things that were said in the conversation quite as much, so it'll weight them less, and it'll like weigh heavier towards newer conversations. Obviously agents, which you've heard a lot about, and then orchestration, how do you put all that together? But this leads us to the fact that agents use data differently. When humans look at data, they're trying to interpret, like, the classic example, your flight got canceled. It's like, oh, okay, well, I'm going to need to query new flights. I'm going to need to query like weather to see why that flight was canceled. I'm going to need to look at prices, like all this sort of stuff. Agents actually take a more speculative path. They explore certain options, and then they're searching more broadly across the data that they have. And the way in which they explore can be a little bit slower, and that's where things like cache augmented generation can really help, where if it already has explored that path in the past, if it's a stateless agent, it might not know not to re-explore that path, but you can cache that query and say, hey, you've already looked here actually, don't worry about that, move on. And then how are we securing these agents? So you heard a little bit about it in the first speech today. They talked about how if you provide some information to an agent, you might not want that context to spill over into other conversations. How are we hardening our access controls around agents? How do you make sure that they have the information that they need and not too much more? And this can help in a lot of ways, not only from a security standpoint, but also from making sure that it's not going too far beyond its intended purpose, and not providing additional information, getting confused by other sources. How can we automate data sensitivity and classification? So I do work for a government contractor. That being said, they're beyond the government. They do have classification and data sensitivity, ways in which companies decide, who should have access to what data, and those access controls. And so figuring out how to do that automation is going to become more and more important to understand how do you give automated access to agents and make sure that we're not having context spill. And then we've got semantic layers and data products, and that's really what I'm going to be talking about through the upcoming demo. So I realize a lot of people might not have heard of a data product, but more or less the very simple version is you might have a lot of data. in a lot of different tables, kind of all over the place, but you can bring that together to make something that serves a meaningful purpose. By doing a query of a single table, you're able to get a full picture of something, and it usually comes with things like documentation on how to use that, some potentially data contracts, depending on how you're setting up potentially a data mesh or something along those lines. But it's pretty much synthesizing data from many sources into one place that makes it so that you don't have to do a bunch of joins. And then agent-friendly governance, how do you make it so that the governance evolves along with the agents? So getting into this, we have a demo. This is a very military-oriented demo. You can think about it not as a military ship, but as a cruise ship. The last time I was on a Carnival cruise, it definitely looked like that. So in this example, I built out some agents using Databricks, something that was previously mentioned. Databricks is a partner with us, and they have a tool called AgentBricks. It allows you to deploy agents through their data platform very simply. And you can tell it, hey, you get access to these tables. It will know how to query. It has a few models that you can choose from. And from there, you can take that and ask it questions like a chatbot. You can give it tools. There are a lot of ways that you can set up orchestration. But the purpose of this demo today is to show how you can still use an agent and set it up wrong, set it up for the opposite of success, failure. And just because you're using an agent doesn't necessarily mean that it's going to be good. So there's still a level of design and framework that you are going to need in order to make sure that your agents are giving you the right answers. So for this demo, this ship has 300 people on it, a mix of staff and line. It supports 6 different meals that they'll theoretically make some of these workers. And due to limited storage capacity, some of its ingredients have been depleted, and it has a certain amount of inventory on the ship. So the goal here is to allow natural language chatbot to help senior personnel understand the decisions they need to make around like how much food, how many meals could we serve the people that are on the ship? Pretty basic question, and a pretty reasonable one. When you're out at sea for a while, you can't always just, restock. So you got to know how much you need to restock, maybe a few other questions. And so let's take a look at this. So this is a naive approach to LLMs, and we're going to run this on some third normal form data. Don't worry about too much of the text on here, but the key takeaway here is that what I've done is taken a bunch of data that is in third normal form, which is a lot of reducing data redundancy, which used to be a really big thing for a while, but is now less of a concern given the speed of indexing databases, a lot of the technology that's come along with databases and being able to query faster no longer always requires this unless your data is like massive. And even then, some of those joins will slow you down. So again, that idea of data products comes into play. But I've thrown it a lot of data, and it's going to have to make a lot of assumptions about joins that it's going to make and other things, and then it's going to try to give me an answer. So again, very naive approach to this. And so here you can see that I have raw inventory, and this was based on like, it's not exactly data that the government uses, but it's based loosely on the structure that we actually did see. And so you've got all these different tables of like items, inventory units, what location it is, raw personnel, which is just the people who are on the ship. And this is actually a sample of those personnel, so we can see all the fake names, what their role is. In this case, I added rank and SSN just to show some examples of like sensitive data that like aren't really germane to the problem, but might have been in that table anyways. And then the ship name, which is not standardized right now. So it's kind of all over the place. There's some assumptions that are going to have to be made there in terms of doing the data cleansing. And then right at the bottom over there, the raw recipe, the ingredients, the recipes, and then like you'd have to merge those together to understand which ingredients go to which recipes. And so All of this is in extremely relational form, very not LLM friendly, and that rank and SSN is available, the ship name's not standardized. So let's look at what we got here. So if every person on the USS Triton was fed tuna pasta twice a day, how many days would supplies last? So the first thing it does is recognize that of 300 people that are on this ship, it assumes that there are 57. And it is making the assumption that we want to, or I guess this isn't the assumption, but it recognizes that we need to feed people twice a day. It says supplies will last 0 days. We can make 25 servings of tuna pasta. I asked it to show its math. It identified that there were 80 servings of salt based on 40 boxes of salt and 0.5 tablespoons of salt per serving. So if we do a little logic here, this is assuming that each box of salt has 1 tablespoon of salt. And in the parts that aren't highlighted, it says I have 200 boxes of dry pasta and 40 boxes of salt. It has made no indication of tuna. And so we are going to make 25 servings of salt and pasta. And I don't know about you, I have had that meal before, but it's not great. And if I was on this ship, I'd be pretty unhappy. And I'm also asking it who our highest ranking officers right now has access to that information, and it's able to list out a few people. I actually didn't give it any information about how ranks work, so it did kind of figure that out. But it probably shouldn't need that information if its primary purpose is to tell me how many people I need to feed. So let's rearrange this. So the first thing that we're going to do is create data products. We're going to join a lot of those tables together. You were seeing, up to like 7 tables for some of this raw data. There's really no purpose of having that. We can combine it together, make a little data product of, our inventory, a data product of our personnel, which the personnel didn't need to be joined, but we can certainly clean up that data still. We can standardize it. And then all of the recipes, we can combine those together. We'll have a bunch of redundant data here and there, but as long as we maintain some of those raw tables at a different location, we can continue to create data pipelines that will create these data products for us that will make sure that things are up to date. You don't have to worry about updating your data product in terms of referential integrity because it's already being done on the normalized data. The next thing we're going to do is create an agentic approach. So instead of giving one LLM and one agent the entirety of all the data, we're going to have an orchestrator agent. We're going to give each data product its own agent, and then we're going to create a validator agent. And we're also going to give these system prompts. So a system prompt is when you're telling that agent, hey, this is some information about the data that you're looking at. Here's some context of what it is you're trying to do. And it will be able to give better results when asked, hey, how many people are on this ship? It's going to have a better understanding of, oh, okay, they're all on this ship. The ship name could be this. It's going to synthesize all that together. And then we're also going to create information security. We're going to remove the ability for it to see the SSN and ranks because it's not really important to what it's being set up to do. And that looks a little bit like this. So again, we've got that orchestrator agent. When the user comes in, it's going to ask the orchestrator agent some questions. That orchestrator agent is going to then divvy up some questions to the inventory personnel and recipe agent. This is also faster in some cases because it can do this in parallel. And so each of these calls is going to an agent. The agent's able to think about it, return some information, and then if it needs more information, it can go back to the agent, but it's going to synthesize that information and use the validation agent to ensure that all the information looks correct, that we don't have any logical inconsistencies. I think I also told it how much a box of salt is, based on my own Morton's box at home. And so we create data products. So this is now what it looks like. You can see that in the data products category, we just have one table for each of the things that we previously had multiple tables for. And we have things like quantity and unit. A big thing is that when you have quantity and unit separated, a model might not necessarily know that it needs to match up that quantity with that unit. And let me say right now, these column names are substantially better than what you will see in some systems. A lot of these systems, especially if it's an older system that people were creating, was the only people who ever saw those column names were programmers. There's not a single vowel in any column name. It is practically impossible to understand like what it was unless you have subject matter expert level of expertise towards like that system. So these were already nice column names that I gave it, and it still like didn't quite understand what to do with everything. So yeah, I can tell it like, hey, in the system prompt, hey, that quantity goes with that unit. So let's look at this again. I've asked it the same question now, but with a much better version. It immediately correctly identifies that the total personnel is 300. It is showing me that my meals per day is 2, and that we'd need a total serving of 600 per day. It actually provides me the recipe, which does include tuna. And it also notes that it needs garlic powder and black pepper. When querying the available inventory, it notes 200 boxes of pasta, 300 cans of tuna, 40 boxes of salt, and that we're missing garlic powder and black pepper. Now, if you wanted to improve the system prompt, you could tell it, hey, things that are listed as spices, if we don't have them, it's not the end of the world. Missing an ingredient like tuna could be a bigger deal. But it's doing its limiting factor analysis, and it's determining that the cans of tuna appear to be the limiting factor, and that only gives us a half day. It also notes that the recipe cannot be completed as specified, and that the canned tuna is the primary factor, but it still gives me an answer, and it gives me an answer that's logical. I think I also added into the system prompt, like, hey, if you cannot adequately define information, please just tell me that. Over trying to come up with an answer, and so I gave it some level of threshold to take an out if it was having trouble answering the question. And so when I then ask it who are our highest ranking officers, it says that it cannot read from that database. It doesn't know anything about rank. It does say 72 personnel. That is actually kind of not inaccurate. It had to do with based on the line staff distinction, but it recognizes that it can't see that. And what you could even do is allow it access to the metadata of that table to say, hey, this column does exist, but you don't have access to it. And then that way it could tell whoever is querying, hey, we do have that data, but you don't have access to it right now. And this represents some important ideas of pass-through of identity and access management, where if I'm a high enough ranking officer, maybe I should have access to that. I could pass through to the AI my credentials, and it can then use that to query the table if it needs it, but then it's blocked from things that I should not have access to. And all of this is really important because, like, obviously you can set up a system that is, a lot more loose, and you do your own prompt engineering and everything. But all of you are here at this AI conference. You're learning about this prompt engineering. Potentially the person on the other end of that chatbot has no idea what prompt engineering is, and they're not going to, think, oh, I should tell it if it can't give me an answer that it should return nothing, or they're not going to think like, oh, I need to make sure it knows how to match up the units with the quantity. They have no idea what the back-end data that it's querying off of looks like. So this is really where it's your responsibility as someone developing something like this to make sure that your user is comfortable using this. You want it to feel more seamless to them, not like they are an adversarial actor to your chatbot, trying to get it to trick it into giving them the correct information. And so that's really the power of data products, and structuring your agents in a way that makes sense, in a framework that makes sense. And you can obviously go into very small tasks for the agents. How big those tasks are, I really don't know if I could answer that, because it's classic consultant answer. It's going to depend, yeah, depending on what your level of tolerance is for where your answer range is, how big the task is, you might want to break up more agents, you might want to break up fewer, you might want to change a few things. So With that, I'll move into some question and answers. There is more, but I just figured I'd take a break here. And if anyone has any questions so far, open it up to the floor. Can we get a microphone over there? You can just shout out your answer and I'll repeat it.
You talked about potentially giving an agent the ability to take your credentials and run it against the table to receive the data that it needs to answer a query.
My question is, how do you deal with potential privilege escalation when you're dealing with a multi-agent system and an orchestrator? So if you pass your credentials that give access to sensitive data, could it pass those credentials on to other agents, which then can cause a cascading failure of data privacy?
Yeah, so the question was about the passing of credentials overall through agents. That's obviously going to depend on your framework and depending on how what pattern you use to set up your agents. Those agents might be stateless, so it might not be the end of the world that you've passed on a credential to that agent, because right after it's done returning the query, it's going to forget everything. But obviously for a stateful one, you'd want to be careful, and that's where you do have security concerns, and you should be hopefully knowledgeable if you're developing these systems of this is a scenario where I need to be careful, and this is one where we're covered from the security side. And overall, just-in-time privilege escalation is always a big thing with things like zero trust. So I think that technology is slowly getting better, but definitely maybe lagging a little bit. But I think that's what we'll start seeing more of. Any other questions? Okay, we'll keep going. Oh.
So you mentioned quite a bit about security. How would cybersecurity be integrated into AI just as a whole? Because I do want to touch on the guy's question without a security clearance and so on and so forth. It's not just that can, well, let's be real, really mess up with AI. So how many other security concerns could be potentially spotted, and how could they be quenched?
Yeah, I'll start with security is definitely not my background. That being said, security is everyone's job, as they will tell you. And so I would say that there need to be more frameworks that come out around this, because certainly every day and with every new feature of some of these models, there seem to be new exploits. This is going to become very similar to the CVE patches that you're expecting from doing any software development. But one of the start things is telemetry. So kind of pulling data out of your model and monitoring it as it's going. So what sorts of questions is it doing? What sorts of queries is it doing? How is it using the tools? And then how are you pulling that out as your model is in production to understand what sorts of things it's doing? And that goes even beyond security, if the efficiency of the system that you've set up. So you want to make sure that if you are seeing it, repeatedly search the same thing, maybe you switch over to caching that search or something like that, something that can help improve the performance. But certainly that is one way to understand, hey, is that model accessing things it shouldn't be able to access? What might be causing that? And setting up alerts across your system to understand, hey, this data was accessed and it shouldn't be, or that's an unusual access pattern. And hopefully catching that in testing, not in production. But obviously, you're not going to catch everything in testing. But I think that the approach generally for AI right now should be more security forward, give it less, and figure out how to give it access as needed. And as they develop more, security frameworks around it, implementing those, I'm sure other people have better ideas around this than I do. But yeah, even from the network side and stuff, the things that some of these models have access to is kind of crazy. Even chatbots on rental car websites will potentially leak user data and things like that, depending on if you can trick them accurately. I did apply for an apartment, and I tried to see if the AI that they'd set up would lower my rent. But eventually, I guess they had a good security measure because it just stopped responding to me at some point. So I think that it understood that I was testing the waters. Any other questions?
For your data products, how are you measuring good enough when you go? Obviously, your examples were terrible to pretty good. So how are you measuring your changes to your data and kind of making sure you're not making wrong data based on your joins and things like that as you feed it into the AI?
Yeah, that's a great question. And we've honestly been doing data products long before we were really focused on AI. And that comes from the fact that inherently when you're doing analysis on data, you don't want to start from the raw data every time. You want to make a data product where, hey, like every person that comes in to work with this data is making these same joins. Why should we make them go through the mental exercise of figuring out how all these joins work and then doing them when we could have one data pipeline that's doing that? It's correct. It can have subject matter expertise embedded within it, and then we can make that one accessible. And instead of reusing the same compute that's going to hopefully make a good data product every time, leaving that up to every person to do on their own. And that's really where like the idea of something like a data platform comes in handy, or something like Databricks comes in handy. It's what we've used on Advana a lot to help with disjointed systems all across the government, be able to bring those together and say, hey, what's the relevant data that people go after a lot when they're looking at something like logistics or something like personnel, and where are people combining those, and what provides the most value. And a lot of that, again, is going to come from subject matter expertise. Your humans on the ground who've been working with that data for the longest time, even if they're not the ones that know how to do the data engineering, they're the ones that know these are the relevant pieces of information that you're going to need, and here's how you're going to get it.
As you're preparing your data products, do you have any thoughts or best practices or whatever how to deal with either null data fields or missing data sets? If you're looking for monthly information but you've missed a couple of months, so that it's interpreted appropriately by the LLMs and agents.
That is a good question. I don't know if I have seen that too much, but certainly if you have a field that's mostly null, I would think that when you're creating the data product, you'd want to measure the value of, hey, is having this field be null so often worth the few times that it's not null? And what is the interpretation of null? And I think that a number of databases, so we use Delta a lot, open source, flat file way to query data, but you can add comments to your columns, and I believe that LLMs should actually be able to take in those comments as well and help use those for context as well. And so if you know that a null doesn't necessarily mean anything bad, it just means that like, hey, that data wasn't available, or like that field wasn't relevant here for this line of data, then you could even add that in as part of a comment, or either as part of the system prompt and let it know, hey, this is like, you can safely ignore this, or if this is missing, this actually, potentially means this other thing. But I think a lot of it comes back to what is the context of the data. In terms of missing data, I would again add that into the system prompt. If it was like the system went down for a month and they had to do repairs on it, and so we're missing this large chunk of data, I would let the model know like, hey, that data is missing. It might theoretically be able to determine on its own, but if you feel it's important, and again, depending on who your user is, how much they know about that data, do they know that that month is already missing, or might they not know about it? You might want to add it into the system prompt so that it is aware that it needs to tell the user, hey, there's this gap in data, and when I went to pull data, that gap was apparent. So again, a lot of these come down to working with your subject matter experts and the people who have worked side by side with this data to help modernize.
Hey, great talk so far. I had a quick question about what the future looks like as far as setting up agents. Is this what 5 to 10 years looks like? We're going to keep going toward. I know it's hard. It's like if you could just give your own kind of guesstimate, is it better to have more of these small agents that are fine-tuned, probably better for security and whatnot, but as like regular LLMs can take in more and more tokens, and you can have these more generalized AI bots? Like, do you still think that the future is going to be fine-tuning these smaller agents?
I am going to touch on this a little bit later as well, but I think that it's sort of your cost-benefit analysis. Like, is it worth tuning that agent too much farther, or are you getting good enough? And should you just give the rest of the information to the human? Because you can spend an infinite amount of money constantly tailoring a system, trying to make it perfect. The fact of the matter is, even that infinite amount of money is going to take some amount of time to implement. And in that time, the technology could be outpacing you. And again, the acceleration of this technology is so much faster. So 5 to 10 years, I am almost willing to bet that agents won't be the big topic of conversation anymore. Like that, I don't know, 90% certain, but it'll be the next thing that agents helped make or help pave the way for. And, it's going to be a question of staying on top of it and understanding how the technology is changing, how that affects the systems that you've built and the products that you've built, whether or not it's worth the investment to move on to the next thing or stay where you are. And sometimes it might be worth it to, just like the new iPhone, skip a generation or something. Like, you don't always need the newest, which is, I feel like, a controversial thing to say at a conference like this. But it's true. You don't, if that benefit is so marginal, the cost to rework your entire system around a marginal benefit might not be there, and you might have instead a different litmus test that you're using for when do we want to switch over our framework to something else. And so this all has to do with the robustness of what you're doing. But at least for right now, this certainly can help with a lot. The number of the other talks I've seen, I think that if you do your agents correctly, they can really help reinforce issues that you're seeing with, this information isn't quite right, or the response it gave is mostly there, but we can obviously see where it's a little off. They can really help reinforce that. So if you are looking for a production system, I mean, this, I hope, was simple enough that it's not like you need to be a computer scientist to wrap your head around I'm just going to assign each person one individual task and they're going to be good at it. So yeah, I hope that answers your question. Another question?
How do you suggest mitigating updates that occur in the source system? Being Booz Allen, I'm sure you're quite familiar with Deltek.
Yep.
And how they like to randomly change table names in updates and sneak those in, and keeping that from blowing up any existing queries and things like that. Or even, I manage the business architecture in the pools and everything like that. So when they want to come up with a brand new idea, and now we're out of characters and we have to change how we do things because we're out of characters in this realm. How do you mitigate those risks and not having to reinvent everything?
So I so thankfully don't deal with Deltek changing their table names, but I do deal with Deltek. So I do understand the frustration there. But one thing that you can do is, have your agent set up to monitor versioning. So if you've seen a schema change, it wouldn't be too hard to have an agent that monitors schema changes and says, hey, we noticed that this column went to this. Theoretically, what it's going to see is this column no longer exists and this column now does exist. That could be a rename. It could be a delete and add a new column. And it can probably look at the data and make that judgment of, hey, all this data appears to be the same, but the column name has just changed, or this is a completely new column, new type, new everything. And so it might be able to then help update your queries through maybe some sort of model context protocol to say, hey, we noticed an update to those. We need to update the queries so that we're pulling the right things, and it can help version your code along with the versioning of the tables that are downstream or upstream. No more. We'll move on. So I want to go over some agentic patterns. I did shamelessly steal this from LangChain. I actually really like their documentation a lot. It gave me a lot of ideas for like, oh, I didn't really realize that you could just do that in code. And so reading these documents was really great. And I realized that what I had set up was just one of a few patterns that they recommend for setting up agents. So I'm going to try to go through these decently fast, but there might be some questions. So we just saw what I did, which was pattern 1, subagents. So the user makes a request, you have a main agent, an orchestrator agent, and it's going to federate queries to its subagents. So, hey, how many personnel are on this ship? What's the recipe for tuna pasta? And how many ingredients do we have of the things that make up tuna pasta? And each one of those agents then replies with its answer. It takes that information and says, what should we do about that? And then it provides its response. This might also look like, user, buy me coffee. The main agent sees that, says, okay, I got a coffee agent. I'm going to call that agent. That agent knows how to use the tool buy coffee. It buys a coffee. That tool replies that it's done and that the coffee has been purchased. The sub-agent then responds back to the main agent and says, I bought the coffee. And then the main agent is the one that is the only one that interfaces with the person, saying, yes, we've purchased the coffee for you. And that's very similar. In this example, it doesn't really display where the subagents work well because it's using a single subagent. It feels like, why would you need to do this? But again, think back to the example I'd previously shown you where we had 3 subagents. That's where it becomes particularly helpful. The next pattern is what's called a handoff. This is where the user is going to request something. It's going to hit an agent. That agent A, B, or C, is going to receive it. In this case, agent A receives the request. Agent A can either fulfill the request, or it will know agent B or C should handle this request. And it can either hand off to agent B or agent C, or if you are agent B, you hand off to A, C, etc. And then whichever agent can correctly handle the response, it's then going to reply. What does that look like with coffee? User says, buy me coffee. Whatever agent it initially chooses determines whether or not it can make the call or it needs to transfer. In this case, it's going to transfer the coffee agent. That coffee agent is going to buy the coffee. And when that is done, it's going to directly tell the user, I bought you the coffee. A stipulation I'll make here is if tomorrow I haven't used any of these agents, I go to fulfill the same order, buy me coffee. Instead of going to agent A again, it's going to start with the last agent that it asked. So it's going to, again, go to the coffee agent to start with. And so you can think about that as cutting out the entirety of the main agent, and I'm just going right to the coffee agent. It's buying me the coffee and telling me it's done. Then we have pattern 3, which is skills. So the user requests something from the agent. The agent has a series of skills that it can use. It then reaches out, calls a tool. That tool then replies with the context it needs to have the skill of doing that action, and then it will respond. And what that will look like is the user says, buy me a coffee. The agent loads up the coffee skill, gets a reply back with how to buy coffee. Then it makes the buy coffee call and then tells the user that it is done. So it's like assuming this identity versus always having a pre-programmed identity. And the last one is a router. And this is where the user requests something, the router routes to a sub-agent or to an agent, and then that is, as many agents as it potentially needs. It synthesizes the data and responds. This is very similar to like pattern 1 and pattern 2 a little bit, but you're always going to hit the router, and the router is always going to route, but it can route to multiple at the same time. And so what this looks like is you're asking the router, buy me a coffee. It's invoking that query with the coffee agent. coffee agent buys the coffee and returns that it's done. And then putting all of these together, you're going to have to figure out how to compare. And I think that this is important because it really shows that like it's not just about the fact that we have agents. This is the fact that we have frameworks around how agents could theoretically work. There's like opinions that need to be made effectively as to what is my user doing, why, like how are they interacting with my system, what is going to make the most sense. And there are a bunch of levers that you can pull around, how many calls are you making, how many calls are you making with repeated requests, in multi-domain, how many calls are you making, and how many tokens is that taking. So these could all be big things that kind of change how you're setting something up. And this becomes more and more important because you need to understand what is your process, what are your user patterns, things like that. And so for choosing these patterns, again, what you're optimizing for, these single requests, so the handoff is really good because it's going to pass between the agents. The router is also good for a single request. For the repeat request, the router is kind of redundant because it's going to hit the router every time, and the router is just going to be passing to the same agent versus the handoff, you're immediately going to that agent if you have a repeat request. But then the handoff isn't very good for parallel execution because it's not going to be talking to multiple agents. Instead, they're just handing the problem one person to the next. It's like your telephone tree whenever you're calling to change your flight or cancel your credit card or whatever, and they route you 7 times to a different person that you give all of your information to every time. Large context domains, so sub-agents can handle them better because each one is only receiving a smaller context, working off of that and then passing back. It's like sort of like having a conversation and then filtering it down and passing that back. So your orchestrator agent is dealing with a lot less context than it would if it had to deal with all the different things the sub-agents are dealing with. And then simple focused tasks, obviously that skill one is really great because it can just swap out skills. But I assume that we'll see more of these sorts of patterns evolve and these frameworks evolve overall. And this is what it's going to be really important to keep on top of is, what makes sense and what makes sense for my use case. So I want to revisit the verification versus validation real quick. What we're used to is something that's validated but not verified. ChatGPT listed it as less common, but I feel like it's fairly common. It's this idea that, we're building something and it doesn't quite work right, it's buggy. There's just something about like we know what it is we want and it doesn't quite do that. That's a very simple problem to solve. It's how do we get it to do the thing that we want it to do. But the one that I really want to talk about is when you're verified but not validated. So that is you're meeting all of your requirements. You've set everything up. You've done the project management part mostly right in that you have a set of requirements. You're building a thing. But when that thing does not meet what the problem is, then it's worthless. You could have a system that adequately, takes your Starbucks order and, tells you what the total and taxes and does all the math right. If that system was for someone trying to land a plane on a tarmac, it is very not helpful. But it could have done everything right. It calculated all of your totals. It took your order and everything. But that plane is not landing. And so at that point, you've completely missed the point. And I think that that's really important because so often I'll see people really get hung up on we set these requirements and these requirements are our be-all end-all. They're not. You need to always understand what your actual problem statement is and what it is that you were trying to solve. So I was at the Houston airport recently, and I had heard about, in the early 2000s, the Houston airport received a bunch of complaints about how long passengers had to wait for their bags. And clearly, it was enough of an issue that they set out to solve it. I have no idea how much money they spent on trying to solve it. But so what do we think solved it? Do we think that there was an increase in system efficiency, maybe the conveyor belts? They cranked them up to 11, they just went faster, or that they drove a little faster to get the bags to where they needed to go in baggage claim. Do we think they just hired more people, they threw more resources at the problem, and that was it? Or do we maybe think that there's a third, more mysterious option that they went with to solve the issue? Well, I'll let you know that they tried increasing system efficiency. They hired more staff, and they managed to reduce that wait time from 9 minutes to 6 minutes. How many complaints do you think they received after this? Yep. It was the same number of complaints, and this was a really Herculean effort to try to solve this issue. And I really tried to look up how much they spent on doing this, but they couldn't quite solve it. Or they couldn't get that number down because in the end, people get off the plane and they were there waiting for their bag. Eventually, I don't know if this is a folklore at this point, but a regular employee suggested, hey, why don't we park the planes further away? So instead of increasing their system efficiency, people walked a little bit longer. And because they walked an extra 6 minutes, the perceived wait time for the bag was 0. It was already there waiting for you. This is a great example of where, increasing the efficiency of something only gets you so far. You can continue to throw resources at it all day. But in the end, you have to examine whether or not the process that you're using is really the correct process to begin with. And you might not need to increase the efficiency of a bad process. In the end, you're just going to still have a bad process. You're just going to have a very efficient bad process. And so I think a lot of this has to do with what are your success metrics, and particularly how do you avoid vanity metrics? Vanity metrics are things that look really good or sound really good, but really kind of mean nothing. There are kind of 4 key categories to this. Is your metric understandable? If you're spending more time explaining the metric, you're spending less time actually acting on it. And even something is kind of air quotes, simple as tokens. A token is just this idea that a word represents, a number in a database, very simply put. But that can be kind of a hard metric for someone who's very non-technical to understand when you're telling them about oh yeah, only took, we saved 3,000 tokens. And then the conversation with that non-technical person is going to be, oh, that's cool. What does that mean? It's it's kind of like a few paragraphs of words. Okay, but if your tokens, correspond to your costs, then maybe your metric is more along the lines of hey, we're going to try to reduce our costs. And then also you're not too focused on tokens as being the only way to reduce your costs, if that is the thing that's important for you. So something that's easily explainable to anyone. You don't want to overcomplicate your metrics. You want something that's comparative. So your metric exists within a context, and you need to be able to compare something. And you want to be able to compare to your competitors or past performance. And it should be something that's meaningful, not apples to oranges. So if your company provides 7 different models for your product, and the other leading company provides 5, and none of those models overlap, who's to say what company is better? Do you just want to pump out models all day? At that point, it's a race to the bottom with who can provide the most models, even if those models don't provide any value. And so that's not really what you want. You want to avoid something like that. I mean, it sounds great, and it's so great that you have all these options, but you want to prove that those are actually providing value. A good success metric should be a ratio or a rate. That rate helps provide context as well. So, if I had 500 errors that we detected, that has a very different context if it's 500 errors over 10,000 requests versus 10 million requests. And so by putting it into that context, you're not just looking at a vanity metric of, again, how many models do we have? Maybe it's, how many people are using each model or something along those lines. Something that, provides a positive or negative value if it moves in one direction or another. And finally, and I really think this is the most important one, it should be behavior changing. And this is always the first question you should ask yourself is like, depending on what the value of this metric is, what am I going to do differently? I've heard asked a few times, like, how do we get AI adoption among our employees? And I ask you this, if your employee adoption for whatever AI is 15%, 84%, 62%, what are you going to do with that? You're going to put that in an investor call? Like, if you don't have a meaningful way to act on that, like, was the AI good? Did it make your employees more efficient? Did it like help them do their jobs better? Were they just interacting with it? Like, there are all these questions left unanswered. The adoption rate of AI, to me, I don't care. But like, if my best employees are using it, and that represents 5% of the company, maybe that's much better than if, you know, I only have, if I'm selling a physical product and the only people using AI at my company are HR, then I'm probably not increasing how much product I'm selling. And so that doesn't really matter to me. So I think that you need to really ask yourself, like, what are we doing with these metrics? And that sort of question will help you define, you know, what should my metric be? What is the thing that I care about the most? And all these examples are to say that, and a reoccurring theme across not only my talk here, but I feel like a lot of other people's talks is context. Context and subject matter expertise become extremely important through all of this transformation at the end of the day. And so that leads me to talk about the human side of working with AI. Obviously, AI is going to continue to grow, and it's going to allow for a lot of efficiencies. It's going to allow you to move fast. Who knows? It could even help you with your profile picture when you have a talk that you have to give at an AI symposium and you don't have any good headshots. So it's going to continue to grow in ways that we don't even, we can't predict. Everyone, I think, would agree on that. But those human interactions are going to be important, and the people that you want to stick around are going to be the people who are coming up with the idea of move the plane a little bit farther away, or that understand how to use AI, understand the frameworks that use AI, and that context engineering will continue to grow. Humans will continue to be an extremely important part of that interaction with technology as it grows. And AI speeds up this process, but it's really not going to fix a broken process, and unprompted especially, unless your process is like so bad that the AI's first thing is like, I don't know why you're doing this, but and you could use AI to identify a broken process, but the important part is going to be identifying that process is broken. And it's going to be your subject matter expertise, experts at the end of the day who understand, like, hey, as this technology grows, maybe there's a better way we could be doing this. We made these decisions at a time when technology looked like this. Technology has now moved to a different point, and that opens up a world of possibilities. You need to be able to reevaluate decisions that you made, not close the door on previously made decisions. And in the end, you have to examine what your sunk costs of implementing AI are. I had previously touched on this a little bit, but you know, is that last mile worth it? How much time do you want to spend? And again, the first speech of the day, they were talking about 16 months to roll out a new product, to 12 to 8. These cycle times are going to get faster. How much time do you want to spend implementing that last mile AI and fine tuning it and making sure that it's like secure, has all the security it needs, versus, okay, this is good enough, we're going to move on, and when the next iteration of things comes and we have to completely undo all of this, we're now primed and ready to do that, versus we're spending all this time maintaining the previous system and trying to get it perfect so that we don't have to do anything at all. And then I'll also leave you all with the question of how are you all prepared for things like chip shortage, or if laws change around the use of AI in certain fields, or the hardware that you have to deploy, whatever your solution is, changes and doesn't support your favorite model, or something along those lines. You're working under new constraints that are kind of beyond your control. I mean, a lot of the stuff that NASA works on when sending rockets, they don't have supercomputers out in space that are able to do these things. They have to consider how do we do this on the hardware that we have that we can send out into space? And all these become very important questions, but the one underlying thing that you're going to have continually are the people that are working on it, the people that you're relying on to integrate this properly, make sure that the proper business decisions are being made, make sure that the process makes sense. And that is all I have. If you'd like some further readings, I assume, do slides get sent out? Slides will be sent out. All these are links. Highly recommend this top one. It talks about the different ways that AI interacts with data, those Lang chain docs, again, shamelessly stolen photos, and this Google Venture talk. This is from over 10 years ago, but I've never seen something more relevant. I think about it so often, and it's where I got the plane example. There's a great example of, which I've heard brought up like 3 times, of spam emails no longer being riddled with errors. He talks about the fact that they've always known how to speak English perfectly, but if you send someone an email with broken English and they reply to it, they're a lot more likely to give you your credit card than someone who just replied to an email that looked correct. So they're really just playing the numbers game as well. They've got a good success metric. Highly recommend checking that out. And yeah, any more questions, or come find me after.